Today I'm going to teach you how to solve a 3x3 system of equations using elimination and back substitution. This is a topic that is in the geometry honors curriculum, but I understand that all of you have been taught this, so I need to go over this so you can solve these types of equations for our partial fraction decomposition, some of the more complicated ones that we're going to get to. So what I have here is three equations, three variables. The variables are x, y, and z, and our job is to solve for each one of the variables and check. And like I said today in class, if you're trying to solve for one variable, you have one equation. Two variables, you need two equations. We have three variables, we need three equations, or else we can't solve for them. So the elimination method of solving these is to first take a look at all of the coefficients and see if you can eliminate one of the variables easily through addition or subtraction. And if I look through this, I can see that if I subtract these two equations, the y is going to be eliminated. And if I multiply this by 3 and add it to this last one, the y's will be eliminated. So what you're going to do is you're going to write down what you choose. So you're going to choose the y's to eliminate. And to keep track of these equations, I like to label them with capital letters. I call this capital letter A, B, C. And to eliminate the y's, what I'm going to do is subtract A minus B, these two equations. And then I'm going to multiply A by 3 and add it to C, because those y's will then add up. So I'm going to be doing those two things. You have to do two separate additions or subtractions for two of these equations to get rid of the y's, so you can come up with a 2x2 equation. So we have 3a plus c that will also eliminate the y's. So you have to do this twice. So a minus b I'm going to be doing first. And a minus b will give me a new equation with just x's and z's because the y's will be gone. And I like to give this a name too. I think I'll call this equation E. So when I subtract a minus b, I have x minus 2x, which is negative x. The y's go away. Z minus a negative 4z is plus 5z, and 6 minus negative 15 is 21. And then we have 3a plus c, and I guess I'll just call him F for lack of a better name. And 3a, I'll just go up to this a equation. I'll just lightly write in a 3 when I multiply everything. So 6 times 3 is 18 here. And when I add these together, I'm going to get 3x plus 5x, which is 8x. The 3y's will go away. 3z plus z is 4z, and 18 plus negative 10 is 8. So now what I have is a 2x2 equation. And I can do elimination again here by just multiplying e by 8 and adding them together because I've got a negative here. So if I do 8e plus f, I will eliminate the x's, and then I can solve for the z. And then the back substitution part is once we solve this for z, we can plug it into this equation, one of these two, and solve it for x. And then once we have x and z, we can do back substitution in one of the three original problems, and we can get the y variable value. So let's take this e and multiply it by 8. So I think I'll just write it down here, 8e, which is negative 8x, 5 times 8 is 40z, and 21 times 8 is 168. And if I add these together, I'm going to get the x's go away. This becomes 44z, and 168 plus 8 is 176. And hopefully 176 will divide by 44 evenly. I've already done that, and you get the answer of z equals 4. So there's one of your values. And now back substitution. You can choose either one of these two equations. It doesn't matter. I guess I'll choose letter E. Back substitution says E will give us negative x plus 5 times 4, which is 20, equals 21. So negative x equals 1, so x equals negative 1. And then the last one, we're going to do back substitution into one of the original equations. So I'll just take the original equation, x plus y plus z equals 6, which was letter A. X plus y plus z equals 6. Well, x is negative 1, y we're figuring out, z is 4, and this becomes 3. 6 minus 3 is 3, so y equals 3. So now I've got the value of all three variables, and we can just do a quick check with our three original equations. Equation A says x plus y plus z equals 6. And we've got 7 minus 1, 6 equals 6. So that one checks. We're going to check in original equation B, which says 2x, which is negative 2, plus y, which is 3, minus 4z minus 16 is equal to negative 15. This is 1. 1 minus 16 is negative 15, so that one will check. And then we're going to check in C, which says 5x, which is 5 times negative 1, minus 3y, which is minus 9, plus z, which is plus 4, equals negative 10. So negative 5 minus 9 is negative 14, plus 4 is negative 10, so that one checks too. So these all check out. Let's go through another one. These just take a few practice problems, and once you get the knack of it, it's not really too hard. So we'll do another one together, and then I'll give you one to try on your own if you'd like to. Here's a second example of a 3 by 3. They all kind of look the same. The numbers are just a little bit different. So just some more practice on this in case you didn't get it the first time. So I'll just talk through these problems. X minus 2y plus z equals 7, 6x plus 2y minus 2z equals 4, and 4x plus 6y plus 4z equals 14. So I'm going to call these equations A, B, and C just for reference. And if I look down through these, it looks like if I add A and B together, I'm going to get rid of the y's. And it looks like if I multiply A times 3 and add it to C, I'll also get rid of the y's. It's kind of similar to the last problem, I guess. So I'm going to just write down at the side, I'm going to eliminate the y's, and you have to do that twice so you can get a 2 by 2 system as a result. So to eliminate the y's, I'm going to do A plus B, equation A plus equation B, and then I'm going to do 3 times A plus B, because I'll get a negative 6y plus a 6y, which will get rid of the y's. So A plus B, I will call my new equation, I called it E before, I don't know why I skipped D, oh well. So I'll call that equation E. A plus B is 7x minus z equals 11. And then the other one is 3a plus b. So if I go up here and multiply everything by 3, I get 3x minus 6y plus 3z equals 21. So I get 7x, which is very nice. And the y's go away. 3z plus 4z is 7z is equal to 21, and 14 looks like it's 35. And so now this is even easier. I'm going to eliminate the x's by subtracting, I'll call this equation F, E minus F. So when I subtract those two, it looks like I get negative 8z is equal to negative 24. So z looks like it's 3. So then I'm going to do a back substitution into one of these two problems. I guess I'll take E, back substitute into E. So it's giving me 7x minus 3 equals 11, 7x equals 14, so x equals 2. And then I'm going to do back substitution into A, I guess. Doesn't really matter which one I take. So the original A said x minus 2y plus z equals 7. So that'll give me, my equation A says x is 2 minus 2y plus z was 3 equals 7. 2 and 3 is 5. 7 minus 5 is 2. So negative 2y is equal to 2. So y is equal to negative 1. And now I just want to check to make sure I'm right. And to check into equation A, it says x minus 2y plus z equals 7. 2 and 2 is 4 and 3 is 7. That checks. Check into equation B. It says 6x, which is 12, plus 2y, which is negative 2, minus 2z minus 6 equals 4. Let's see, 12 minus 8 is 4. 4 equals 4. That one checks. And equation C says 4x, which is 8, plus 6y, which is negative 6, plus 4z, which is 12, equals 14. 8 minus 6 is 2. 2 and 12 is 14. So that one checks. So there's our system of equations. And then if you want to try one on your own, I have one for you. I have a lot of them that you could try. But if you want to try this one, it's similar to the other ones, I guess. 3x minus 2y plus 4z equals 0. X minus y plus 3z equals 1. And 4x plus 2y minus z equals 3. So you can go through, if you want to eliminate the y's first, you can. It looks like that might be the easiest thing to do because you can add the top and bottom equations together, or however you want to do that, but you're going to get down to a 2 by 2 and then do some back substitution. And that leads us to the problem that we left off with today. And the problem we left off with, we kind of got to a different state in each class. In my period 2 class, we got to the point where we said negative 1 is equal to a plus 2c plus 2d. Negative 8 is equal to 8a plus 4c minus 2d. And 0 is equal to 4a plus 6c plus 3d. That was my period 2 one. Now period 5 had the same equation up here, except everything was doubled. We had negative 2 equals 2a plus 4c plus 4d. So what you can do with that equation, period 5, is you can just take half of each term, and you'll get the same thing that period 2 ended up with. Both of the classes, I believe, came up with this equation, but in period 2, we took half of each coefficient, so it ended up being negative 4 equals 4a plus 2c minus d. Period 2 ended up with this equation because we let x equal 3. And if you let x equal 3, you would come up with this. In period 5, I think we let x equal negative 2. And we came up with another equation that I didn't write down. So this is for the period 5 people. If you can write these 3 equations down, just remembering that this was the same that you guys got, but everything is half because we just divided both sides by 2. This is the same as you got, and in period 2 we let x equal 3. And if you go through the equation that was that we came up with for partial fraction decomposition, you would get this in the end. So right now we have a 3 by 3 system of equations. Instead of solving for x, y, and z, we're solving for a, c, and d. And the other problems that I gave you, we had these constants over on the right-hand side. Well, it really doesn't matter. But what I'm going to do is I'm going to look through all of these equations right here. And I'm going to see that A is probably going to be the easiest thing for me to eliminate. If I multiply this by -8 and add them together, that'll get rid of those A's. If I multiply this by -2 and add those two together, that'll get rid of those A's. So let's do that. Let's multiply this first equation times -8. So -1 times -8 is +8 equals -8a minus 16c minus 16d. This next equation, I'm not going to change him at all. This just says -8 is equal to 8a plus 4c minus 2d. I'm going to add those two together to eliminate the a's. So we get 0 is equal to -12c minus 18d. The next thing I'm going to do is I'm going to take this third equation and I'm going to multiply that one by -2 and add those bottom two together to get a second equation with only c's and d's in it. So this equation, if you multiply through everything by -2, you're going to get 0 is equal to -8a minus 12c minus 6d. Everything gets doubled and negated. So now I'm going to add those two equations together, the second one and the third one times -2. And when you add those, you get -8 is equal to, the a's went away, -8c minus 8d. So it looks like we can divide everything by 8 if we wanted to, but I want to get these values to line up. Let's see. If I multiply this top equation by 2 and this bottom equation by 3, or -3, then I can eliminate the c's. So let's multiply this one by 2. So I can get a -24c here. Let's multiply this third one by -3 so I can get a +24c here, and so we can eliminate those c's. All right, so I'm going to take this down and I'm going to multiply this by +2. So this becomes 0 is equal to -24c minus 36d. I wish. This next one, -3 times -8 is 24 is equal to 24c plus 24d. And when you add those together, you're going to get 24 is equal to -8d. So that means d is equal to -3. Now we're going to do some back substitution. We can do some back substitution into this equation. That's probably the easiest one. It really doesn't matter which one you use. And I think I'm going to simplify this equation and just call it -1 equals -c minus d. I just divided everything by 8 so it'll be a little bit easier for me to work with. So back substitution, you get -1 is equal to -c minus d is +3. So when you subtract 3 from both sides, you get -4 equals -c. So 4 is equal to c. And then we're going to back substitute one more time into one of these original problems from up here, which says -1 is equal to A, which we don't know, plus 2C, which is 8, plus 2D, which is negative 6. 8 minus 6 is 2. Subtract 2 from each side and you get negative 3 is equal to A. So now we've solved for all three of these. Negative 3 is A. Oh, something went wrong. All right, let's see if we can catch my mistake. I'm going to go back. I'm going to shut off the video right now. Let's see if I can catch my mistake. Well, I found my mistake way back up here. Negative 36 plus 24 is negative 12. So I'm changing that to a negative 12. So D is equal to negative 2. Good thing 3's can change into 2's pretty easily. All right. Now when we back substitute, we get negative 1 equals negative C minus D. So this would be plus 2. And that would leave C being equal to 3 instead of 4. And then back substituting, negative 1 is equal to A plus 2C, which is 6, plus 2D, which is minus 4. And we still have the same answer because 6 minus 4 is 2. Negative 1 minus 2 is negative 3. So I just made a little mistake in my D's and C's. So if you remember from before, B was negative 1 and C is 7. So what we're going to do is we're going to put all that together and we're going to write it as the A value was negative 3, so we have negative 3 over x. B was negative 1, so we have minus 1 over x squared. C was 3, so we have 3 over x minus 1. D was negative 2, so we have minus 2 over x minus 1 to the second power. And E was 7 over x minus 1 to the third power. So that would be the answer to question number 20 from our textbook, using a 3x3 system of equations using the elimination and back substitution method. See you tomorrow.